Hey guys, welcome back to another video. So here I'll be going through a complete topic walkthrough on everything involving with arithmetic series. Now what I did is I've collected and solved 6 different past exam questions in the IGCSE Edexcel syllabus, and I made sure each of these questions are actually a mixture of very easy to difficult, and there's nothing missed in between. Now before we have a look at these 6 questions, what I want us to go through first is actually a topic list and just to make sure that we've got everything covered. Okay. Now for arithmetic series, there are 5 major topics, and these are the topics. The first one is the basic, which is to find an nth term of a sequence, and I call it UN. So this nth term is just your usual regular linear arithmetic sequence, something you've seen a lot of times. Now the second part is like an extension of the first. Here we need to use worded problems that involve the nth term, so just pretty much converting a whole paragraph or text or line into an nth term expression. Now the third part is kind of unique. They want us here to find an nth term from 2 terms. So what this means is, like, for instance, in your question, they might give you a third term, which I call the U3, which is equal to 7, and they might give you a 7th term, which is equal to 19. And using these 2 random position terms, we need to be able to find a general nth term, UN. Now that's all. So that's pretty much the first 3 covering nth term. Now as for the last 2, the fourth one talks about the sum of the first n terms, and here I call it Sn. Now this literally means, for instance, that you want to add up, let's say, the first 5 terms, and whatever the total is, that will give you the Sn value. But in your case, you might get something very complicated, like add up the first 1,000 terms, and there's a nice formula to use there, and we're going to get to that in a second. And finally, and this always comes up at the end of either paper 1 or 2, maybe like question 21, 22, 23. And these are the harder problems involving both the nth term and the sum of the n terms, okay? And usually to solve these, we need to use simultaneous equations, okay? And you're going to see this through some of the questions. Now, let's check out the formulas, guys. So there's 2 important formulas for us to learn, yeah? The first one, which is the standard nth term formula, which is the a plus n minus 1 multiplied by your common difference d. Okay, and I've labeled what everything is. A is your first term, n is the number of terms, and d is the common difference between each term. Okay, now this formula is not given in the exam, so you have to memorize this one. But fortunately, this big formula is given, so you don't have to memorize this, but we need to recognize what it is. This formula here is the sum of the first n terms. So if you had 100 terms in a sequence, you replace n of 100 and replace obviously your first term a and your common difference d, and voila, it gives you your sum of what those 100 terms would have been. Now I put 2 examples what they actually mean in context. For example, if the question said the 20th term, this literally means find U20, and plug it in. All you do is replace n with 20, and we know 20 minus 1 is 19. If you know what a and d is, well, you're going to get the result. Another case could be the sum part, Sn. If they told us to find the sum of the first 20 terms, this literally means find S20. In other words, replace your n values here with 20. And of course, if you know a and d, well, plug it in too. Okay guys, so now that we've completed this topic breakthrough, let's jump straight into the questions. So I'm going to see you guys in a minute. Ciao. So here are the first 5 terms of an arithmetic sequence. Okay, so you got 7, 11, 50, and so on. So we can see they're going up in 4s, so plus 4. Write down an expression in terms of n of the nth term of the sequence. Now the nth term formula is very straightforward. I mean, you can memorize it by 1 or 2 methods. I'm going to use the formula method. So the formula is always this. It's always the first term a plus n minus 1 times d. Okay, d being the difference, okay? So looking at each string, so we can see that the first term a is 7, so it'll be 7 here. And we can see it's going up in plus 4. So it'll be plus, so it'll be all of this lot, n minus 1 times 4. So timesing this by 4, you're going to get 4n minus 4. And just tidying up now, collecting like terms. So you're going to have 7 minus 4 is 3. So it'll be 3 plus 4n. That's it, guys. All you have to do. So here are the first 5 terms of a number sequence, yeah? Find an expression in terms of n for the nth term. Okay, so before we even do this, we look at the sequence and we ask ourselves what's happening. Well, it looks to me like they're going up in plus 6s. And now for part A, when they want you to find the nth term, a nice little trick is to literally ask yourself again, what is it going up in? Well, it's going up in 6s, so it'll be 6n. And then we just circle 10 and just go 1 back. If we subtract this by 6, we get plus 4. And that's it, guys. That's literally my way of finding the nth term. Alright, part B. So the nth term of a sequence t is given by n squared minus 3. Okay? There are numbers that are terms in both sequences s and t. Find one of these numbers. Okay, what this is actually telling us is that both of these sequences must have the same term. Now, if they have the same term, there's a good chance that at some value of n, these two equations will be equal. So we say, alright, this is telling us that n squared minus 3 must equal 6n plus 4 at some common n value. And that's it. Now, to literally evaluate this, let's go ahead and move all these terms to the left side, yeah? So subtracting 6n and subtracting 4, you're going to get n squared minus 6n minus 7 equals 0. So now, in order to solve this so simply and easily, we could just use a quadratic formula, where a is 1 is the first term, b is minus 6, and c is minus 7. So the terms in front of the values, yeah? So using the quadratic formula, it looks a bit like that. It's minus b plus minus the square root of b squared minus 4ac over 2a. Now, by the way, guys, some of your calculators can already solve this. So if you can just put in your calculator the quadratic formula, you can just skip this part. For everybody else that wants to use a formula, let's keep going, yeah? So for this bit now, replacing minus b, since b is minus 6, minus b will become plus 6. That'll be plus minus the square root of b squared, which is minus 6 squared, minus 4 times a times minus c, all over 2 times a. And again, putting this all in your calculator, but first using the plus sign, we're going to get a result of, let's see, 7. And if you use the minus sign, you can get a result of negative 1. So now we have to choose which of these two values do we keep. Well, for the nth term only cares about your position, so the first or second or third. We can't have a negative position, so the only answer is 7. So the value of n must be 7. And so here are the first 4 terms of a sequence of fractions. Okay, so it looks to me that the numbers on the top half are going up in 1s, and the bottom we have odd numbers going up 2 each time. Okay, so the numerators of the fractions form the sequence of whole numbers 1, 2, 3, 4. The denominator, the bottom half of the fractions, form the sequence of odd numbers. Okay, just like we said. Now A, write down an expression in terms of n for the nth term of the sequence of fractions. Okay, so what this actually means that we need to find the nth term for the whole numbers and an nth term for the odd numbers, and then put them on top of each other as a fraction. So to do it simply, for the whole numbers, and I'm going to do this really quick and easy and fast, and that'll be the top half. We ask ourselves firstly, what's it going up in? Well, we know it's going up in 1s, and then we ask ourselves secondly, what is the term before 1? Because we need to know what the 0th term is. So if it's going up in 1s, the term before 1 must be 0, so it'll be plus 0. Now for the second sequence, we do the same thing. We ask ourselves, what's it going up in? Well, it's going up in 2s, so it'll be 2n. And then the term before 1, before the first term, and you can only get that if you go back by 2, because everything's going up in 2. So if you subtract 2 from 1, you get minus 1. And that's it, guys. This is literally your expression. But simplifying this, of course, 1n plus 0 is just 1n, and 1n is just practically n. So it'll be n over 2n minus 1. And that's it. That's your expression found. Okay, part B. So using algebra, prove that when the square of an odd number is divided by 4, the remainder is 1. If they use the word even number, by the way, an even number is always going to be 2n. Whereas an odd number, and this is just it's a clear definition, yeah, be 2n minus 1. So these are properly defined here, so there is no other ways to write them. Okay. Now to prove this, it says prove that when the square of an odd number is divided by 4, so we need to take an odd number, do the square of it, and then divide it by 4, we get a remainder of 1. So alright, let's try this out. So all you want to do is literally expand this term. So 2n minus 1 is literally 2n minus 1 times 2n minus 1 over 4. Now multiplying out the bracket using FOIL, in other words, you do 2n times 2n, 2n times 1, and so on. You're going to get 4n squared minus 2n. Then you got minus 1 times 2n and minus 1 times minus 1. That gives us another minus 2n plus 1, all over 4. So we're going to have 4n squared minus 4n plus 1 over 4. So we're going to have 4n squared over 4 minus 4n over 4 plus 1 over 4. Now what happens here? So when you divide this by 4, these two cancel out, so 4's cancel out and 4's cancel out. So we're left with n squared minus n plus a quarter. Now, what does this actually tell us? Well, this tells us clearly that firstly, you get a whole number here when you divide it by something, and you're left with a remainder of 1 when you divide by 4. And that's it. So really, all they really wanted to see is that you get a quarter, because 1 over 4 is a remainder of 1. Okay, this is the same definition. So the 10th term of an arithmetic series S is 66, and the sum of the first 20 terms of S is 1290. Find the 5th term. Okay, so to do this nice and easy, let's write down all the formulas we know about arithmetic series. First, we have the nth term, which I'm going to call it un. It's always given by a plus n minus 1 times d. And then we've got the sum of the first n terms, which by the way is given in the front of the book, is n over 2 times 2a plus, the same thing, n minus 1 d. So that's just a general formula for the nth term, like basically a position, and the sum of the first n terms. Now it tells us from information that the 10th term is 66. So if we rewrite the first formula, we can say that a plus n minus 1d. So a plus, since we know it's a 10th term, n is 10, so it'll be 10 minus 1, so 9d, must give us a result of 66. And we know that the sum of the first 20 terms, so s20, so we're going to have 20 over 2, which is 10 times 2 times a. And here, since n is 20, it'll be 20 minus 1d, so it'll be 19d. And it must equal 1290. Okay, and just to simplify further, if you divide 10 across, you'll be left with 2a plus 19d equals 129. Alright, so what do we do next from here? So now if you look at both these equations for a second, yeah, before we even solve the question, let's try and figure out what the value of a and the value of d is. And by the way guys, I didn't say this earlier, but a is the first term and d is a common difference, yeah? So to solve this simultaneously, various methods, but what I'm personally recommend is to just go ahead and double this equation by 2, yeah, and subtract it from this equation here. And when you do that, you're going to have, at least when you double it, you're going to get 2a plus 18d equals double 66, 132, yeah. And that's it. So now we just solve this simultaneously. Subtracting the equation, you'll be left with d equals negative 3, which is perfect. If you know what d is, you can plug into the first equation to get a. So we're going to now have a plus 9 times minus 3, which is minus 27, equals 66. Adding 27 across, so 66 plus 27, you get 93. Okay, so it looks like we've done it. Now finally, they want us to find the 5th term of S. So the 5th term, let's call it U5. And using the general form, which is over here. A, since we know what A is 93. N is going to be 5, so it'll be 5 minus 1, which is 4, times d, which is minus 3. And then putting this in your calculator, you're going to get 81 for the 5th term. So it says 2x plus 23, 8x plus 2, and 20x minus 52 are 3 consecutive terms of an arithmetic sequence. Consecutive means each one follows on, like 1, 2, 3, 5, 6, 7, or in twos. 2, 4, 6. So that's what they pretty much mean here. Now it wants us to prove that the common difference between each sequence is 12. So they're adding 12 each time. Now to prove it, there's a nice trick here. You could say that, for instance, the difference of these two terms must equal the difference of the next two terms. That makes sense, because if you had something like 1, 4, 7, 10, we can see that the common difference is 3. Now if you subtract each one, so let's say 4 take away 1, that must equal 7 take away 4, which must equal 10 take away 7, which is all 3 each. That's what they want us to see. So what we want to do here algebraically is subtract the common differences. So let's do 8x plus 2 minus the first term. So we're going to have something like 8x plus 2 minus 2x plus 23. And it has to equal the difference of the other side, so 20x, I don't need to put brackets by the way for the first terms, minus 8x plus 2. And it looks like we're going to try and find the value of x here. So let's do it. So on the left hand side, 8x take away 2x is 6x. You could expand the bracket. It's up to you how you want to do this. 2 minus 23 is minus 21. Now on the right hand side, 20x take away 8x is 12x. Minus 52 minus plus 2, in other words minus 2 is minus 54. Okay, so now we're getting somewhere. So what we could do is make x a subject. So let's make x a subject on the right hand side, because you've got 6x which is smaller and 12x which is bigger. So subtracting 6x, this will disappear and this will drop to 6x. Adding 54, this will disappear and you add 54 here. So we're going to have 6x here. 54 minus 21 is 33. Oh, so now we want to divide this by 6. So x is going to equal 33 over 6. So 33, is that divisible by 6? It isn't, is it? 5.5. Okay. I don't know, to me this honestly looked kind of wrong, guys. That's why I was a bit surprised. I was expecting a whole number. Anyway, since x is 5.5, let's go ahead and plug into the original values, yeah? So plug in 5.5 for here. You're going to have 2 times 5.5 plus 23. This is going to become 34. Plug in 5.5 there. So let me just quick recap. X is 5.5. We're going to plug this into all the equations, yeah? The difference is clearly 12 each time. And that's it, guys. I hope you enjoyed this walkthrough. You know, if you guys liked it and it was beneficial, please give me a like and share with your friends and your classmates, you know. Now let's have a read. So we've got the sum of the first 48 terms of the arithmetic series is 4 times the sum of the first 36 of the same series. So what's that saying is that the sum of 48, when n is 48, is equal to 4 times the value of the sum of the first 36, which makes sense, I suppose, for whatever reason. Now it wants us with this equation to find the sum of the first 30 terms of this series. Okay, oh man. Now all you have to do here is literally just copy this equation twice, replace n with 48 here, and then again on the right hand side replace n with 36. So let's do it. So for the sum of 48, we're going to have 48 over 2 times 2 times a, and by the way, a is known as the first term, by the way, if you know even if we know what it is, and d is the common difference. We have to figure out what these two are, I'm guessing. Alright, this is going to be equal to 2a plus, so n minus 1, so because 48 minus 1 would be 47d, equal to 4 times so s36, 36 over 2, I'm just going to make it quick, which is 18 times 2a plus 35d. Okay, and then 48 over 2 is 24. Alright, so it looks like we have two non-similar equations, I guess. Right, now what do we do next? So now we've got this information. Let's go ahead and see if we can hopefully tie this up here. So expanding the bracket, you're going to have 48a plus, what's that, 24 times 47. Okay, so you get 1128d. That's equal to, sorry, for this one you want to do 4 times 18 first, just to avoid any error. And that should give us 72. 72 times a is 144a plus, now 72 times that I don't know in my head, so it's 2520d. Alright, so at this step you're probably thinking, what should I do next? Okay, well, first things first, let's go ahead and collect like terms here. Let's subtract these two across. And doing so, I already did it and I got 0 equals 96a plus so on. Okay, so that's fine. However, that's not it. We can also, you know, I thought, okay, let me just find an expression for the sum of the first 30 terms. And doing so, I got this. So that's also easy. Now, at this point, this is the part where it can really confuse you. The question is actually just noticing that all of this actually equals 0. So possibly we might need to factorize this to make it look like the S30. And the question is, how do you factorize it now? What term to pick out? Well, my tip is to probably see if it's possible to get some number that leaves you with 2a plus 29d. I mean, if you can't do that, then the question is a fail. There's nothing we can do. So the only way to do this, and I'm not looking at this number, but I'm looking at 962. To get 2 left inside, you would have to, well, divide it firstly by 2, and you'll notice that you you would have to divide it by 48 to see this possible, yeah? So let's have a look. Dividing this 1392 by 48, and I haven't even tried it, but let's see. You get 29. So in fact, all of this one is divisible by 48, and that means that all of this is equivalent to 0. So actually, you know, just ignore 48 because you can cross it out now. 2a plus 29d is 0. That means this is 0. So 15 times 0 is 0. And that's it, guys. We're done. That's the end of the question.